Okay, we're going to continue the idea of finding trig functions of all angles, not just angles in a right triangle, not just acute angles. All right, and we just talked about finding reference angles in the last video. Now we'll kind of put those two ideas together. How do we use that to find the values of the trig functions at an angle without using a calculator, okay? So you need to work on this because to get credit on quizzes and tests, you're going to have to be able to reason things out similar to what I'm going to be showing you. So one of the things we're going to need to be reminded of are the ratios of the sides in these special triangles. So go ahead and draw yourself a 30, 60, 90 and a 45, 45, 90-degree triangle and write what the ratios of the sides in those triangles would be, okay? All right, and then let's go ahead and work all these problems. All right, so if you're being asked to do the sine of 300 degrees, okay, the intent is not for you to just type sine of 300 on your calculator. It says to use reference angles to find the exact value of each of the following trig functions, okay? So when they ask you that, what you want to do is you want to draw a picture. You want to think about where 300 would be. So this would be 180, this would be 270, so 300 should be right here, okay? And then the reference angle would be this angle. So the 300 degrees theta is this, but your reference angle is the angle right here, okay? And so you should think about it as, think about dropping a perpendicular to the x-axis. That's supposed to be a straight line right there. And the theta prime is actually this guy right in here. See if I can write them small enough. So that's my theta prime, okay? All right, so that's what I want to know, is what's theta prime. We get that drawn a little bigger, okay? And clean that up a little bit. I'm trying to draw that terminal side. That's 300 degrees. Okay, so here's what you want to think. So yeah, this was 0 degrees at the start, and then one full revolution would be 360. So you can see that the theta prime would be the remaining 60 degrees you would have to go, okay? All right, so what you're going to do is you're going to do the sine of 60 and get what that is, and then you're going to have to look at, to determine the sine of 300, you're going to have to look at what quadrant 300 degrees is in to determine whether to add a negative in front of it or not. So do you see where we're at and how we're down below the x-axis? So we know that sine is negative down here, right? Sine is negative in this quadrant. So we are going to need a negative on that. So what you're going to do is get the sine of 60 and then just put a negative in front of it. And that's it, okay? So when you're trying to do a sine of 60, you can go back up here and look at your 30, 60, 90 triangle. We want the sine of 60, so we want the opposite, which is square root of 3, over the hypotenuse, which is 2. And then if we're in the fourth quadrant, sine is negative because you had to go down. So this is the sine of 300, negative square root of 3 over 2, okay? All right, let's try one that's in radians. Okay, so draw your triangle. Draw your angle. And so we're trying to do 5 pi over 4. And when you're doing radians, don't change it to degrees necessarily. Just kind of think about where you would be. So I'm cutting up 180 into 4 parts. So this would be 1, 2, 3, 4, 5. This would be 5 pi over 4 right here. Okay. All right, now for my reference angle, okay, I like to think about a little triangle here, and this is what I'm using for my reference angle, okay? And so what I would do is I would figure out what that is and see how that angle right there is just 1 pi over 4. So what I'm going to do to find tangent of 5 pi over 4 is I'm going to do the tangent of just pi over 4. And then I'm going to come out in front and put the appropriate sine there. But we're in the third quadrant, aren't we? And in the third quadrant, okay, this went over here, okay? So over here, we're in the fourth quadrant, so sine was negative. Over here, we're in the third quadrant, we're dealing with tangent. Tangent is positive when you're there because both x and y are negative in that quadrant. So this will just be a positive. So all we got to do is the tangent of pi over 4. And you see how pi over 4 cuts 180 into 4 parts? That means it's 45 degrees. So I'm going to be focused on the 45, 45, 90, trying to do tangent. That's opposite over adjacent. So that's going to be 1 over 1, which is 1. And so the tangent of 5 pi over 4 should be 1. Okay. So by finding these reference angles, we're finding an angle that is actually acute. And then we're basically able to do what we did back in section 5.2, okay? Because this reference angle, the sine, cosine, or tangent of it is related to the sine, cosine, or tangent of the original angle. All you got to do is modify the sign that's out in front, okay? So let's try a couple more. Let's look at secant negative pi over 6. So you're always going to want to be drawing a picture. You don't draw a picture, you don't get credit on that when I want you to explain. Okay, so when you're thinking about that, you should be thinking about splitting up pi into 6 pieces, and you just want to go 1 piece around. So since you cut it into 6 pieces, okay, do you see how that means you're cutting 180 into 6 pieces? So this would be the negative pi over 6. Your reference angle for that would be pi over 6. So theta is negative pi over 6. Theta prime is pi over 6. All right, and pi over 6 is 180 divided by 6 is 30 degrees. I do need that because, you know, when we're thinking about our special right triangles, we're thinking about 30, 60, 90. So you got to remember to go and look at this 30, 60, 90 triangle. And then you could go and think about the definition for secant, but what most people do is we're going to just do cosine because cosine is related to that. So I'm going to do cosine not of negative pi over 6, but of pi over 6. That's cosine of 30. So that would be square root of 3 over 2. Okay. And then I could go from there to thinking about cosine of negative pi over 6. Okay, so I have to think about the quadrant I'm in. See how I'm down here? That's in the fourth quadrant. See how I'm to the right? So that means it's going to be positive. Okay, so it would equal positive square root of 3 over 2. So it turned out to be the same as the cosine of pi over 6. See, pi over 6 would have been here. So the cosine of pi over 6 and the cosine of negative pi over 6 would have been the same because the x, oops, that's not where that right angle should go, because the x coordinate would have been the same. Do you see that? You would have been to the right, okay? All right, but I didn't want cosine, right? So now I'm to the point where I know the cosine of negative pi over 6. Let me pull it up here. So I know that the cosine of negative pi over 6 is square root of 3 over 2. And so secant should be the reciprocal of that, 2 over the square root of 3, and you've got to rationalize that. So that would be your final answer, okay? All right, let's try cosine 17 pi over 6. All right, so starting there, one time around would be 2 pi. But if we have a denominator of 6, it might help you if you think about it as 12 pi over 6. See how 12 over 6 would be 2? If I went around again, that would be 24 pi over 6, okay? All right, so let's see where we would be. So if we go around one whole time, that would be 12 pi over 6. And then you should be thinking about this broken into 6 pieces, the pi being broken into 6 so you can count. So we're all the way around to 12. Then this would be 13, 14, 15, 16, 17. So you'd go all the way around to here. Okay, this is the terminal side then. Okay, that's your theta right there. Your theta prime is right in here. Okay, and so theta prime would be an acute angle that we could use to determine the cosine of the actual angle. You see how we're only 1 pi over 6 away? So what we're going to wind up doing is we're going to wind up, let me get rid of some of those. We're going to wind up doing the cosine of just pi over 6. Okay, so that just happens to be the same as what we did a second ago. We found that a second ago, and that was square root of 3 over 2. All right, but now we're in the second quadrant. You see that? We're up here in the second quadrant. And see how you had to go to the left to get there? That means your cosine is going to be negative there. So we know cosine of 17 pi over 6 should be the same as cosine of pi over 6. They should be equal, except you might have to adjust the sign. So that should equal the cosine of the reference angle. Let me move that over just a bit. So it should equal the cosine of the reference angle, which was square root of 3 over 2, but you have to think about whether you need to put a negative in front of it. And sure enough, if I'm in the second quadrant, I do need to put a negative there. Okay. All right, let's try negative 22 pi over 34. Seems pretty messy. Okay, so that's kind of crazy because the denominator is 34. I can't really draw that, but that means if I went all the way to here, that would be negative 34 pi over 34, because it would have been breaking up pi into 34 pieces. So I'm not all the way to there. Okay, and like half of 34 would have been 17. So if I only went this far, that would be negative 17 pi over 34. So negative 22 pi over 34 should be about like that. Okay, I should go around just to right there, and this would be the terminal side for that one. So that's kind of how I reasoned it out. So that's negative 22 pi over 34. Okay, so what I want is the reference angle for that. So if I did that, I would be looking for what this is right here. Just let me erase that little black mark there. I want just this angle, and that angle would be from 22 to 34. So let me see, 34 minus 22. Okay, oops, didn't need to borrow. 34 minus 22. Okay, so that would have just been 12. So that would have been 12 pi over 34. I can cut it down a little bit. 6 pi over 17. That should be my theta pi, my theta prime. All right, well, that doesn't help me though to be able to do this without a calculator. Okay, but I wanted to go ahead, since I had that on my guided notes, and kind of talk through the reference angle part. I can say this, I do know that if I could figure out the sine of 6 pi over 17, I would have to put a negative on it since the angle would be down below the x-axis. Okay, so I wanted to go ahead and do that, but we can't actually calculate the sine of 6 pi over 17. It's not an angle in a special right triangle, so we can't do that without a calculator. Okay, it was probably a typo, and I probably meant for that to be a 4, but that's what you would have seen on your guided notes. So that's really as far as I can go on that one. But do you understand how to get the theta prime? And then how that would mean that you would need to put a negative in front of the sine of 6 pi over 17, okay? All right, now let's try this guy, 9 pi over 4. So again, it's fourths. I like fourths. Okay, because that's cutting 180 into 4 equal pieces. I know all the way around would be 8 pi over 4, so 9 pi over 4 is just right there. Okay, that means the reference angle I'm dealing with is this guy. Okay, right here. And that was just pi over 4 past the 1 full rotation. So the cosecant of 9 pi over 4 should be the same as the cosecant of pi over 4. And see how it's in the first quadrant? That means it's going to have the same sign as that. Don't have to even adjust it. So now I just need to think about the cosecant of pi over 4. And that's really 45 degrees. So I'm going to be thinking about a 45, 45, 90 triangle. Okay. Cosecant is related to sine. The sine of pi over 4 would be 1 over the square root of 2. But normally you would rationalize it. But I really don't want sine. I want cosecant. So the cosecant would be the reciprocal. That's square root of 2 over 1. And because I'm in the first quadrant, it's going to be positive there. So that would be just square root of 2. Okay? So reference angles allow you to take an angle that's not acute. Okay? Find an acute angle kind of associated with it. And the big idea is that the trig value of this angle, the original angle, can be found by doing the trig value of the reference angle. It's just that you have to sometimes adjust the sign and put a negative or a positive out in front of it.